All right, everyone, how's it going? We're going to be doing the final Fluent project simulation here. I'm going to be showing you how to do that. So here, we're going to be constructing a wind tunnel, doing the simulation at different velocities, 5, 10, 15. For this one, it's going to be at 10 meters per second. We're going to create it, get the contours, make some plots along the center line, show some variations, and also showing the vertical distribution. Okay, so we'll get right into it. So the first thing you're gonna have to do is open up your geometry. Make this 2D real quick. Open up your design modeler. All right, so we're going to start on the XY plane. Okay. So as you're gonna start, first thing I decided to start with was to create the center line. Just found that to be a little bit easier this way. Okay, I like to make all three. Now we're going to dimension the lengths. Let's have a quick look at those. Six, the first one. Yeah, two is the second one. And we have 5, 7, 8 is the third one. Okay. So now, little thing we can do to help really center this, because we're going to have to make calculations along this center line. So there's a little trick I found. We're going to center the whole line at the center, also the origin. There's this construction point right at the center, and now go to constraints. We're going to do a midpoint between that construction point and this line. Boom. Okay. So now we have it kind of centered. This is going to help a lot later on. Okay. So now we have the center line done. We need to start creating our sections. So draw 3 vertical lines. Bang. Oh, 4 actually. Do that. Bang. Boom. Okay. Mention these first. We'll need to look at these though. The first one is 6256. The second and third is going to be 0.6096. Last one is going to be 0.8 something, 0.889. Nice. Okay. Now, kind of similar to what we did, we can midpoint these. Little trick I found. Bang, bang, bang. As you can see, just got this constructed. Okay. Just connect these lines. Like so. Just delete all these other parts. All right, so now we have our wind tunnel constructed. Similar to the other projects, we're just going to add a surface to this now. Awesome. First part is done. Now we can go to our mesh. The center point that was created, you're going to see why later. We have to create plots along that center line. So we're going to use that as a reference. So for this one, I'm actually going to make it triangles. Just creates a better mesh in general, okay? Similar to recent. Now we're going to add some sizing. My go-to is always about 10 millimeters. It's been working every project so far. Should look real nice after. This doesn't yes. Been making a while recently. It's a pretty good mesh. Now, similar to the other projects, we're going to need to name them. It's going to be our inlet, where we're going to be putting our selected velocities through. This is our outlet. Okay. And name this walls. Just take a quick look. Awesome. Okay. Mesh is done. Let's update that junkie. Let's go to our setup. Close these. My computer is tweaking. All right, let's get working. Okay, so models similar to before with the K epsilon values. We want to enhance that wall treatment. Show the pressure gradient effects. Okay. Now we're going to move to our materials, fluids, and okay. So density is good, but in the project, it wants us to use Sutherland viscosity 2 coefficients. Okay, you can look those up online. You will find that it comes out to be 1.716. Okay, you can change create. Let's keep that. Awesome. Now we can go to our boundary conditions. Now this is where you're going to change your cases for 5, 10, 15. For project requirements, they want the 10 case to be recorded, so that's what I'll be showing you. Oops. Now let's go to our reference values. They never ever follow what you put in, so you have to put it in yourself. Okay, 2, 10. Let's take that reference from the inlet. Amazing. Let's go to initialize. Okay. Run this calculation. Run the calculation. Sorry, I did some thinking in my head. So 500, it should be around like 70 iterations. So it should be enough. Surprised if it takes longer than that. Now, for the graphics. Now, the parameters it wants pressure, dynamic pressure, total pressure, and then velocity. Okay. To make this a little better, change this to float, apply. Please. So you can see, where the velocity is going to be squeezed, we see the lower pressure. That is pretty accurate. Now, you would screenshot this, put this in your report. Now we can also look at the dynamic pressure. It can almost be the complete opposite of static. Change this to fluid. Now you have your dynamic. Awesome. Now we can take our total. So display close. Here's our total pressure. Awesome. Okay. And now we can do our, oh wait, there we go. It's pretty much the same. Okay. Now for your final contour, you need to record the velocity, magnitude. Awesome. 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 As you can see, as you go through your squeezed section, you have a reduction in area. So this is where your maximum velocity should take place. And then as the area reopens, this is where you will see your velocity start to decrease again. This is pretty accurate. Okay. And now, I'm going to close. So now for the other part of your assignment, you need to make some plots of these variations. It'll open for me. Thank you. Okay, so it wants this along the center line of your distribution. Okay, so for this you're going to have to create a line. Okay, and now this line, so your y value is going to be 0. Okay, Now, here, so we recentered it, so it's going to be a little different. So your natural y position is actually negative 2286, right? 6 plus 2, that's 748. So you have a length of 3.9116 divided that by 2. Our center really right now is at 1.9558, but in relation that is actually 0. So now we're going negative 1.9558. Negative 1.9558 to 1.9558. Awesome. And we want it at 0 to be at the center line. Oh, you can't see my finger. The center line of this test tube create that is going to be our line. Now, let's take a look at the velocity. So, what you're seeing here is saying that it's going to be 0 when it starts. Wait, actually 10 when it starts, not 0. It's going to be your starting inlet velocity. I want to change some things here. So it's saying that this starts at 10, correct? And it's going to go all the way up to peak right at about negative. So this should be where, so this should be right where it starts to go into the test section. So we see that pinch in velocity, area remains constant, so it's going to stay same. And then as it starts to diffuse, you will see the velocity then decrease until it exits. Okay, so that is your velocity. Now we want to see the pressure variation along the center line. We'll save plot. So where there is maximum velocity, there's going to be almost the inverse of pressure or static. So where we have the minimum velocity, you see the maximum static. Where we have the maximum velocity, you see the minimum static, so forth. Now your dynamic pressure, which is related to your velocity, should now be almost the inverse of this. So we should see the opposite hump. Let's see. And that is correct. Almost mimics kind of how your velocity moves throughout the channel. And now when we plot our total pressure, it'll be that relationship between the static and dynamic plot. And this is what you get. Okay. So you would save these, write to file, save, open up an Excel sheet like so, and you would plot these cases for each variation, and then you plot these against each other, as you can see. And this has all the same velocity cases on the same sheet. This should be your total pressure variation. This will be your static pressure variation. And then this will be your dynamic pressure variation. Okay. So that was for the center line variation. Now we want the vertical distribution at the center of that test section. Okay. So now we're going to create a new line that has a singular x point, but then relates to the top of your test section and the bottom of your test section. Okay. So we're going to be right here, going down, up. You will see how you create that line for that. Okay. So now we are going to need a new line. Okay. And your center of your test section is at 1.9558. Okay. And we have to go to the center now of your test section. So I would add the first part plus the length of the test section divided by 2, which is about 1.72 meters. Find the difference between your natural center and the center of the test section. It's about 0.2286 meters. Okay. And now if your center point of 1.9 is 0, then your x point of the center would be negative 0.2286. Okay. And we want it to just stay at that point. But now we are going up and down in the y, okay? Now, your total width of your test section is going to be 0.6096. The center of that would be y equals 0, so then divide that by 2. You would go negative 0.3048 meters down, you then 0.3048 meters up. Okay? Let me create that. Should be line 6. Okay? And now it just wants the same variations, okay? So let's look at that. And if we are right, as soon as you hit that boundary layer, it should be some interesting things going on. So let's see. Okay, so this I kept the direction 1, 0. This is incorrect. So you have to put it now in the y direction. You have to tell Fluent you want to look up and down. As you can see in the bottom of this axis, it's staying at your normal x. Okay, so save plot. Now we are looking at from the top, the bottom of your y section to now the top. Okay. So as you can see here, it's telling us that once we're squeezing against that wall, we're seeing maximum velocity in the y direction, okay? That's where we see our largest values, okay? But it's also saying that it swoops down. So when you look at your dynamic pressure plot, it should be about the same. Should mimic this. As you can see, mimics. Awesome. And now, like we've seen before, static should look interestingly different. Inverse, okay? So it's saying that when we have the minimum velocity in the middle, that's where you're seeing maximum static, okay? And now your total pressure. Awesome. So like before, you would write those to file, okay? And now you would plot the 3 variations against each other, as you can see. Same with the static now. Okay. And then for that now, you can then plot all these on your document. Put them against each other. Awesome. And for the bonus section, all we really do is just import geometry, change a little bit of the meshing to get some more detail right around that airfoil, and create similar plots. Okay? Make sure that should sum up the tutorial. Contours. Contour. Awesome. Okay. Thank you guys for watching.